do that?
Measured one of them, and then divided the entire weight by that one, or something. Okay.
Okay, so with the hole punches, how did you measure those? What did your group do? How did you sit there and individually count every hole punch? It would pick up the mass of one hole punch? It did. It was that sensitive. Okay. So then, if you knew the mass of one of them, how did you figure out how many pieces you had? What did you do next? If you knew the mass of one of them, how did you figure out how many pieces you had in there? What did you do? Somebody did something in here. Come on, let's go. Talk to me. Mario.
We divided the one mass with the mass from all together.
Okay.
Divided those and then rounded up.
Okay. So you took the mass of the whole sample, you divided by the mass of the individual one, and then that told you how many you would have had in that sample. Does that make sense? Okay. And then the salt, you could do the same with. You could count on enough salt grains until you got to the point where you were able to get a mass from it, get the mass of the whole sample, and then divide by that, and then you'd have to multiply by the number of grains you had. Okay? So when you did the pennies, when you worked through that, that was just getting you thinking about dimensional analysis and working through some of that information. Okay? Now, did you find out how many pennies were in 1 mole? Did anybody do any research on that? What a mole equals? Right here's that conversion factor. So this is how many pennies there are in 1 mole. All right? Okay, so today we're going to start out with our notes. And I wanted you to see from the thing yesterday that we can actually be able to figure out masses associated with these tiny little items. Okay, that's what yesterday's exercise was all about, was trying to determine, hey, yeah, we can get the mass of these tiny little things, even though we have a bigger scale. You know, the scale can't measure that tiny little thing. Okay, so you should have your notes out. Your notes should have a diagram on it that looks like this. And you're going to need your periodic table today and a calculator. Get all that stuff out so we can get started. Calculator, periodic table. And you should be turned to the page that has this diagram on it. All right, so when we look at different items, we have different ways that we can count different items. For example, if we have a dozen of something, that means that we have 12. Come on. A baker's dozen is 13. So they throw an extra one in case there's something wrong with one of the items. A ream. So if somebody tells you to go pick up a package of paper in the clerical pool, you come back with that stack that's like bound by paper. That's a ream of paper, and that's 500 sheets. A league is, I can't remember what a league was. Okay, 3.5 miles. So a league is about 3.5 miles. A gross is 144. So that's a dozen is what that is. A pair is 2 and a score is 20. So we have different measuring things for different items. In science, we have one called a mole. And a mole is 6.02 times 10 to the 23rd items. So this is for really tiny little things. So that if we had a mole of something, if that was pennies, like that's a lot of pennies, right? You kind of figured out yesterday how many pennies would fit in the room and that sort of thing. So think about like a dozen paper clips. What does that look like? Can you visualize what that looks like? And then visualize what a dozen students looks like. What would a dozen students look like? Okay. It doesn't look the same, does it? But yet it's still a dozen. So would their masses be the same? A dozen paper clips and a dozen students? No, these would be significantly greater than these. The same holds true with our elements, okay? You can have a sample of hydrogen that is like this, and it's 1 mole. And if you had a sample of aluminum, it might be more like this, and it would have 1 mole, because the atoms of aluminum are much heavier. They're 27 times heavier than this guy. Okay, so when we're looking, the masses are going to compare differently. We abbreviate mole as MOL. Sometimes you will see it with the lowercase n as an abbreviation. They are used to count extremely small particles. So if you thought counting those grains of sand or salt yesterday was difficult, can you imagine trying to count atoms in a sample that are even smaller? You can't even see individual atoms. Okay? So we use this to help us. If we know the atoms that we have and we want to go to moles, we would just divide by 6.02 times 10 to the 23rd. If we're at moles, then we're going to multiply by that value. If we're at moles, we would divide by the mass off the periodic table, and that would get us into, I'm sorry, we would multiply. Yeah. There's something wrong. Hold on. This is wrong. This should be a multiplication here. Change that. That should be multiplication. And that should be division. So you take the grams and you divide by the molar mass to get to moles. So switch that around. Sorry about that. We couldn't use Google Images when I was doing this, and I found this on that dog pile, and I guess it was really a dog pile. No, that's not funny. Trying. Okay, so the mass on the periodic table that you see on the periodic table, for example, carbon, it says 12.6 and we're going to round to the 10th place. That 12.0 is grams per mole. So when they're talking about atomic mass or molar mass here, that's coming from the periodic table. Okay, so that is going to be in grams per mole. This is for carbon. Hydrogen is going to be 1.0 grams per mole. If we want water, we're going to take 2 hydrogens and an oxygen and add them together. That's going to be 18.0 grams per mole. So if I asked you to measure out a mole of water, you go back and give me 18 grams of it. And in that mole of water, there would be 6.02 times 10 to the 23rd molecules. We typically will use dimensional analysis to help us out with this. So you can use this method with this thing as long as you fixed it now, or you can use dimensional analysis. I like to teach it with dimensional analysis, but some people prefer to use a chart like this. Whatever you need to do to get this accomplished is fine with me. All right, if I'm starting at 3.5 moles of C6H12O6, and they want molecules. So for me, I'm going to do moles to molecules. And that's going to be 1 and 6.02 times 10 to the 23rd. I got this conversion factor from up here. That's where it is, right here. See where I told you that a mole is this many items? Okay. The other thing you could do is you could use this guy and go, okay, I've got 3.5 moles. I want to get over to here. This thing tells me I've got to multiply by this value. Does that make sense? Either way, you're going to end up with the same answer. So you need to make sure with your calculator that you have, and I actually want you to go through this. I want you to type in 3.5 times 6.02 to the 23rd. Okay, so for your answer, you should have gotten this on your calculator. And if you haven't, I want you to call me over right now and let me know, because I want to make sure that you know how to use your calculator. If you don't get that value on your calculator, okay, I want you to call me over. Yeah, it's not gonna, for this problem, it's not gonna make a difference, but yeah, you're right, I should change that. There, okay. Did you get it? No, yep, that's 24. Okay, we're good. You get the 24th? Okay, 24th. A lot of people end up getting to the 25th here because they're not putting it in their calculator right. And I want to catch that now before we get too far. Okay, so, yep, times 6.02. Now on this one, you're going to hit that exponent key and then type in 23. Okay? Oh, yeah. So I'm recording this. So pick up from here in the thing. And then homework tonight is 10 to 4 in that packet. I think it's 10 to 4. No, it's 10 to 3. I'm sorry. So it's these two pages. You get it in your calculator, okay? Where's your calculator? Then go up and get one out of the calculator bin affair. It's a wood bin affair on a second shelf. Okay, so you're gonna hit that right there, and then type in 23. There you go. See, that's the same thing. Good? You good? You got 24? 6.02. Okay? Everybody good then?
Yeah, is the homework due today or tomorrow?
This?
10.3.
10.3 is going to be tonight. I think I miswrote on the board. I think it should say 10.3. I'm sorry about that. All right. So that's our answer to that one. Now we're going to do this guy. We're determining the number of atoms in 2.50 moles of zinc. So I want to get rid of moles. I want to go into atoms. So moles are going to go on the bottom and atoms are going to go here. So in 1 mole, I have 6.02 times 10 to the 23rd atoms. That's a times. I also could go back up to this diagram here, and I could write in 2.5. I want to go here, so I'm going to follow my arrow, and it tells me to multiply. So either way, however you want to do it, that's fine. And you should end up with 3.01 times 10 to the 23rd atoms zinc. Make sure you're doing it in your calculator and let me know if you're not getting the right answer.
I think I messed it up.
Did I mess it up?
Oh,
Oh, I know what happened. Yeah. See, this stupid calculator, I do this all the time. This stupid thing, I end up turning the thing on, and the first key that I hit, it doesn't take. And so then it ends up, so I ended up multiplying 0.5 times Avogadro's number. All right, let me try it again, y'all. Sorry. All right, does this look better? No, not yet. There we go. So 1.51. I guess it doesn't look good then, does it? All right, let's try this. Better? Okay. I'm sorry, you guys. Lippy. All right. You ready to move? The next one, we're going the other direction. So this time, instead of being here, we're going to go from here this way. So now I'm going to be doing, it was at 836? 83622. Okay, so 836 times 10 to the 22nd. So we're going this way. We're going to divide by this number. If you want to see what that looks like in dimensional analysis terms, it's going to be 8.36 times 10 to the 22nd. That's atoms of copper. And if I'm getting rid of atoms and going to moles, it's going to be 1 here and 6.02 times 10 to the 23rd here. All right. So hopefully I did this right. I need 3 sig figs, so 3, 9. And that's going to be moles of Cu. Now make sure you're doing this one, because if you're doing something wrong in your calculator, it's going to scream at me right now that you got the wrong answer. And you're probably going to get an answer that's like times 10 to the 40 something if you're doing it wrong in your calculator. So if that's the case, call me over and let me help you, please. Good? Mario, you good? know if you're not getting that value. Okay? This is as much about learning how to do this as it is about learning how to use your calculator. Get it, Pepper? Get this? Yep. Yep. Top times this divided by this.
Okay.
But it's times 1, so you don't need to. Yep, so that you're doing it wrong in your calculator. Okay, so you're going to retype this one. Okay, and this is exactly what I wanted to do, is catch this. You're going to type the 8.36. Now you're going to go to that second button. You're going to activate, see where it says E there. Okay, now you're going to type in the 22. And you're going to hit divide. And then 6.02.
Oh, okay.
And then 7 EE 23. There's your answer. Okay. So did you end up with times 10 to the 45? Anybody end up with times 10 to the 45? That's what I wanted to catch because you're not using these right, okay? Good. That's good. Okay. So we're going to go back. We're going to type in the 8.36. You're going to do that right there. And then 22. Then you're going to hit divide. And then you're going to type in your 6.02. And then you're going to hit that key again. And then type in your 23. There you go. You get it? Good. Anybody else get times 10 to the 45? Because this is the problem that I'll catch on if you're working these out.
Does it go to 139 because you can round up?
Yep. So we had 3 sig figs. Do you see that 8.36?
Yeah.
That's what determines our sig figs. So that's 3 sig figs. So when we're dividing, we need 3 sig figs in our answer. All right. Let's try another one. We're determining the atoms of oxygen in this sample. So this is going to be a little bit trickier, okay? So watch what I'm going to do here. So I've got, and this is where my dimensional analysis comes into play. I've got moles of CaCO3 here. I can't draw a straight line to save me. All right, I can draw them down. I can't draw them across for some reason. Now, I'm going to go moles to molecules here. And we've been doing that. That's been something that we've done up above. It's the next part that might throw you for a loop. Okay, so get that written in, get it drawn like that, and then I'll take you on the next step. You ready? All right. They did not want to know molecules. Okay. Remember, the simplest part of this whole thing when it's together is a molecule.
Wait, what does the second box say?
This?
Yeah.
6.02 times 10 to the 23rd, the same as what this one said, because in 1 mole you got that. Molecules. It's hard to write on this thing.
No, I get that.
Let me try to do it a little better. You're writing down here, but it's showing up in a different spot. And so it's harder to do than just when you're writing and watching where you're writing, you know. It's different. All right, so the simplest part of this that's still, you know, when we break it down, the simplest part is a molecule. And then in each molecule, we have a calcium atom, we've got a carbon atom, and we have 3 oxygen atoms. So it's like kind of like saying, you know, we've got a parking lot out there and the simplest thing out there is a car, right? But really, it's not just a car, it's a steering wheel and a radio and, you know, 3 seats. Okay? So there's parts of it. And so here we're saying in this sample, we've got this many molecules. And now we're going to say, okay, in one molecule, we have how many atoms of oxygen? Well, this is where we're going to get our conversion factor from. For every one of these, how many oxygens do I have? 3. Just like for every car, I have 4 tires. That makes sense? So now when we multiply this across, we're going to have to multiply all 3 of these things to get our answer. Well, you're dividing by 1, but I think you can probably do that in your head. So
wait. I don't need like explanation, but like step by step. Which like, how do we like times it and divide it? Like, what order?
So when you're putting it in your calculator, you're going to take everything that's across the top and you're going to multiply. So 569 times 6.02 times 10 to the 23rd.
Okay.
Times 3. Now, in this case, the bottom is going to be 1 and you're dividing by 1. So you can stop at this point. But sometimes you have to multiply across, then hit your divide key, and then come down here. And if you've got more than just ones down here, you need to put all of that in parentheses and multiply it, and then hit equals. So you multiply across the top, hit your divide key, and then multiply across the bottom and hit equals. All right, so when I do this, 5.69 times Avogadro's number times 3. So I ended up with this for my answer. I need 3 sig figs, so 1.03 times 10 to the 25th, and that's going to be atoms of oxygen. Okay. Did anybody not get that in their calculator when they multiplied this out? Good. You don't need me to help you? You doing okay with it? All right. Okay. So that takes care of going that direction. So we've covered going between these 2 things so far. Now we're going to focus on going between these 2 things. And whereas here we just had this one number, now those numbers that we're going to be multiplying or dividing by are going to be coming off the periodic table. And you guys had some practice figuring out molar masses the other day at the end of 10.2. So we talked about like how to find the molar mass of magnesium salt or acetate. Do you remember me showing you on the board how to do that one? Remember that? So you take a magnesium and 4 carbons. Okay. So that's what we're going to be doing here, grabbing those values off of the periodic table. So when we do these, the mass in grams of 1 mole of any pure substance is called its molar or atomic mass. The molar mass of any element is equal to its atomic mass. It has units of grams per mole. So if we want a mole of helium, we would measure out 4.0 grams of helium. 3 moles of manganese, then, if you look up manganese on the periodic table, manganese is 54.9. So So 54.9 times 3 is going to give me my moles of manganese. Okay, so that's 164.7 grams for every 3 moles. So if I needed 3 moles of this, I could just go back and measure that out on my balance, and I've got it. So here, for water, if we want to figure out 1 gram of water, how many moles that is, we're going to be getting rid of grams, and we're going to be going to moles. So I need to figure out my molar mass of water. So for water, H2O, I've got 2 hydrogens times 1.0 off the periodic table. I've got 1 oxygen. Oxygen is 16.0 off the periodic table. If I add those together, it's 18.0. And that's what I'm going to use for my bottom number here. Or if you are using this chart here, you're going to take those grams and you're going to divide by the molar mass on the periodic table. Okay, so our answer here is 1/18, which is so we need 3 sig figs, 0.556 moles. Okay. So the molar mass of water we just figured out here was 18.0. It's ugly 18 grams. So they want to know how many grams are in 8 moles. So now I'm going to do 8 moles. We want to get rid of moles and we want to go to grams. So when I do that, I'm going to take 1 mole, 18.0 grams, and that's 144.0 grams of H2O. How you doing on these? Okay, is it making sense? All right. Here we're doing 25.5 grams of Ag. I can't draw a straight line to save me. Nope, still can't do it. Close enough. Grams, moles. Where am I going to get my gram value from? Where does this come from? Where am I going to find this? Where did I say up here that we're going to find that information? Where are we going to go? Periodic table. And we're going to find the atomic mass on the periodic table for silver. So that is 107.9. So 107.9 is my atomic mass. And I'm going to divide now. So 25.5 divided by 107.9. That's going to give me 0.236 moles of Ag.
I'm not sure where you found the 107.
Do you have your periodic table? Do you see silver on there? It's in the D block. Second row down on the D block.
Yeah.
Okay. So that's the, yep, I just got it right off of there. Okay. All right. So tomorrow we're going to talk about 2 steps where we go from atoms to grams. But tonight I just want you to practice what you've done here. So I want 10.3 done tonight. Okay. We're not going to do anything with the lab from yesterday. It was just a discovery experience. So you can do whatever you need to do with that. But tonight I want 10.3 done. Okay, and I want it done by tomorrow. Got it? Okay. You got a little bit of time here, I think, before lunch. Yeah, we got about 6 minutes, so you should be working on trying to practice a few of these before you leave. That way, if you don't know what you're doing, you can come up and talk to me real quick and let me help get you where you need to be before you leave.